Hello student, in last video lecture we discussed about instrumentation of mass spectroscopy. Then you remember that analyte is in gaseous phase. Then this gaseous phase analyte when passes through ionization chamber, they produce number of the ions. Then in today's lecture we discussed or discussing types of ions produced during fragmentation. Ionization of analyte forms large number and types of ions having characteristic m/e ratio, means mass to charge ratio. Their relative abundance varies with the type of analyte and ionization condition used. Then there are 13 types of ions produced in the ionization chamber, but only cations are analyzed. Then first ion is the molecular ion, second one multiply charged ion, third fragment produced in ionization chamber is isotopic ion, then fourth ion metastable ion, fifth one is rearrangement ions, sixth is the negative ion, seventh type of ion is the fragment ion, 8 is the radical ion, type 9 is the adduct ion, then 10 is the cluster ion, 11 daughter ion, then 12 fragment in ionization chamber is the dimeric ions, and 13 is the even electron ions. Means there are 13 types of ions produced in the ionization chamber. Then one by one I am explaining here. Then first one is the molecular ion. Here molecular ion M is analyte or molecular ion. Analyte or molecule M. When ionization in ionization chamber, it forms M plus dot. Here M plus dot is called as the molecular ion or parent ion. Then it is denoted by M plus dot or M bracket plus dot. Then for example, I am showing here methane molecule. When methane molecule subjected to mass spectroscopy, it forms molecular ion, that is CH4 plus dot, means removing only one electron when bombarding with 70 electron volt electron beam. Then it is written as CH4 plus dot or CH4 in bracket plus dot. Or I am giving another example, benzene. Then benzene bracket plus dot. When molecular ion is formed, an ion formed by the removal of one or more electron from a molecule without fragmentation of molecular structure is called as the molecular ion. Means from molecule it loses one electron or more electrons without fragmentation of molecule, and the molecular structure remains as it is called as the molecular ion. The molecular ion have odd electron and also positive charge. Therefore I am writing here plus and dot. Then molecular ion is nothing but originally analyte molecule with only one electron less, so its m/e ratio directly gives molecular weight and important for finding molecular formula. Then stability of molecular ion increases if molecule contain pi electron system. Molecule contain pi electron system. Therefore stability order is given here. Aromatic compound is more stable than conjugated olefins. Conjugated olefins, example 1,3-butadiene. Then conjugated olefin is more stable than the alicyclic compound. Therefore stability of molecular ion increases if molecule contain pi electron system. This is the molecular ion, first fragment molecular ion. Then I am again explaining here second molecule, multiply charged ion. Then multiply charged ions are formed by gaining or losing of more than one electrons. Then formation of multiply charged ions. It also doubly and triply charged ions, showing number of electrons lost or gained by ion. Then I am explaining one more fragment, that is the rearrangement ion. Then rearrangement ions formed by transfer of atoms during fragmentation of molecular ion. You studied some rearrangement reaction, that is Pinacol rearrangement, Wagner-Merwin rearrangement. Then in rearrangement ions, they formed by transfer of atoms during fragmentation of molecular ion, or hydrogen or methyl group transfer in case of the rearrangement. Then they are most common in the mass spectroscopy. An example of rearrangement ion we studied further lecture, that is McLeod-Purdy rearrangement. McLeod-Purdy rearrangement is the best example of formation of rearrangement ions. Here gamma hydrogen atom transfer in the McLeod-Purdy rearrangement. Then another ion I am explaining here, fragment ion. Then these ions are derived from sample molecule. It is formed by electrical dissociation or decomposition, or these fragment ions are charged particles. Then fragment ions may be cations, anions or radicals. Here you remember that cations means positively charged ions, then anions negatively charged ions, and radicals means singly electron present ions. Means these ions are derived from sample molecule and it is formed by electrical dissociation or decomposition, then formation of a fragment ion. Then again I am explaining here radical ion. Radical ion may be cation or anion having an unpaired odd electron, so it is ion as well as the radicals. Then in BSc first class you studied homolytic fission and heterolytic fission. In case of the homolytic fission, suppose A and B is the molecule formed by sharing of the electron pair. If homolytic fission is occur, then A acquire one electron, B acquire one electron. Then this type of the homolytic fission, formation of a radical. But if here heterolytic fission is carried out in case of AB molecule, suppose B is more electronegative, then it abstract completely electron pair towards itself. Therefore A acquire positive charge and B acquires negative charge. Means formation of one species cation, one species anion. Or homolytic fission, formation of a radical. Heterolytic fission, formation of a cations and the anions. This is the radical ion. After homolytic fission and the heterolytic fission, formation of a radical ion. Then again I am explaining isotopic ions. Here isotopic ions means the ions containing one or more of naturally occurring isotope of an element is called as the isotopic ion. Isotopic ions means they differ in their mass to charge value. Here isotope of hydrogen, one isotope is hydrogen is the deuterium and another one is the tritium. Means suppose methane molecule CH4, then H is replaced by deuterium, then CH3, M upon E ratio is the 16, and isotopic ion of CH3 cations, M upon E is the 15. Here CH3 positively charged, M upon E carbon 12, 3 hydrogen, M upon E is equal to 15. But instead of hydrogen, we taken here deuterium, then CH2 having atomic weight 12 and deuterium 2, 12 plus 2, here 15. D is heavier isotope of hydrogen. Similarly, isotopic molecular ion of ethyl bromides is the example of a isotopic ions. Then metastable ion, I am explaining again metastable ion. They are short-lived ions of higher excitation energy that dissociate rapidly, sometimes before reaching the detector. These ions appear as broad and low in intensity peaks at non-integral mass numbers. They are useful only for studying fragmentation mechanism. Then again I am explaining here rearrangement ions. Then rearrangement ions, they are formed by transfer of atoms or groups during fragmentation of molecular ion. Here hydrogen ion transfer rearrangement are common, but of methyl group migration are also seen. Then next one is the negative ions. Here negative ions, they are the negatively charged ions formed by gaining one or more electrons. If one electron gain, then formation of, suppose AB molecule acquire one electron, formation of A plus B minus, or A acquire electron, then formation of A minus plus B plus. They are formed specially when the sample in vapor phase is bombarded with electron beam. Three ways they can be formed, that is AB molecule, A acquire electron, formation of A negative and B positive. Suppose B acquire electron, formation of B negative, A positive. For example, O minus, OH minus, C2H5 minus, CCCl4 minus. Then one more ion is the fragment ion. Fragment ion can be also cations, anions and radical cations generated by fragmentation of excited state or inherently unstable parent ion. They contain significant proportion of the original structure. This formula weight is less than the molecular ion weight as they contain only portion of analyte. The uncharged fragment, that is radical, and the small molecule form can't be called a fragment ion. Then fragment ions of methane, toluene we study further. The next one is the radical ion. The radical ions is both an ion and a radical, that is an anion or cation having unpaired electron. Radical means unpaired electron, anion means negatively charged, cation means positively charged. Therefore radical ion is both an anion and radical, that is an anion and cation having unpaired electron. The unpaired electron is shown as a dot alongside the charge symbol as superscript, that is CH4 plus plus, SF6 plus plus. I am showing here example CH4 plus, that is SF6 plus dot, that is sulfur hexafluoride, or CCl4 plus dot carbon tetrachloride. This is a radical ion. Then one more ion is the adduct ion. Here adduct ion usually formed by interaction of an ion and a molecule. It is often generated in ion source, carries constituent of both molecule and ion. Then one more, here dimeric ion. It is an ion produced by an unstable precursor, that is pre-existing ion, either by fragmentation or by acquiring different charge. So fragment ion is a daughter ion, but not all daughter ions are fragment ions. An unstable daughter ion may itself act as a precursor ion and form as the daughter ion. And last is the dimeric ions. Here dimeric ion, it is a cation radical formed by analyte dimer in vapor state. Otherwise it is formed when molecular ion attaches to a neutral molecule in the ion source. If M is an analyte molecule. Means molecule undergoes analysis is called as the analyte. If M is the analyte molecule, then dimer ion is represented as M plus dot. They are detected as such. And last one is the even electron ions. Even electron ion, it is an ion lacking unpaired electron. For example, CS3 plus or C2H5 plus, that is lacking of unpaired electron, is called as the even electron ion in its ground state. Thank you for listening.